Hello and welcome to this session geared towards helping you pass the Praxis Mathematics Content Knowledge exam. My name is Milan Carnes. I am a tutor for Butler County Community College. I am a high school math teacher of 18 years. I currently and have been teaching for the last 12 years geometry, calculus, and AP calculus. My purpose today is to tell you a little bit about the Praxis test and to help you set a plan for success. Because if you haven't taken it or looked ahead at it already, there is a lot of material that you do need to know in preparation for the exam. The material may or may not be on the test, but it can be overwhelming when you do see the amount of concepts. And so you do need to plan and put a good plan in place. And so I am confident that with a good plan in place and the right attitude, you can be successful in passing the test. And that's what I'm here to help you to do. So let's go ahead and get started. We are going to cover three things today in this session. We are going to address test objectives, preparation materials, and practice and preparation. We're going to look at test objectives first. So first, we'll look at where you can find the test objectives and then why you should know the test objectives. The test objectives can be found on the ETS website under Mathematics Content Knowledge 5161 in what is called the Study Companion. So we're going to go ahead and go there and take a look at the Study Companion and the test objectives. So here we have the Study Companion for the Mathematics Content Knowledge exam. And if I scroll down, there is a lot. You can see there that it is 51 pages long, so we're not going to go through all 51 of those pages. I am going to go ahead and skip to page 5, which shows us the test at a glance. And so you can see down here there are two main content categories, Roman numeral 1 and Roman numeral number 2. Roman numeral number 1, your number and quantity, algebra, functions, and calculus make up 68% of the test, whereas Roman numeral number 2, geometry, probability and statistics, and discrete mathematics make up 32% of the test. So then if we go ahead on to page 7, we can see all of the content specifics. So we have our Roman numeral number 1, and that is broken down into each subcategory, number and quantity being 1, algebra, functions, and then finally calculus. And then under each of those subcategories, there is also an objective. So for example, under the A, number and quantity, you see number 1, understanding the properties of exponents, and then that is broken down into 3 points, A, B, and C. So there's quite a bit of material listed. So why you should know the test objectives? Obviously, you need to know the test objectives to know what's on the test. Of course, when you take a test, you need to study and be prepared, and so you do need to know what's on it to be able to do so. Another reason why you should know the test objectives is so that you can learn the vocabulary. So for example, if we go ahead back to the Study Companion by clicking on the book here, I am going to go to Roman numeral number 1, and we're going to look at number 6 under A, number and quantity, which says, understand how to perform operations on matrices and how to use matrices in applications. So matrices are one of those areas that are not used the entire way throughout math. And so, of course, when you don't use it, you lose it. And by reviewing the objectives, specifically this one about matrices, you can see some of the terminology that you may run into when dealing with matrices. For example, B says to multiply matrices by scalars to produce new matrices. So you might see that vocabulary word scalars and think, oh, I don't remember what that is. And so then in preparation for the test, you would want to go and look up that word to see what it means, because you may see the same terminology on the test. And of course, the final reason why you should know the test objectives is to assess what areas need the most attention. So just again, the Roman numeral number 1 from the test at a glance covers 68% of the test. So you definitely would want to give that area a little bit more attention than Roman numeral number 2, which consists of 32% of the test. So once you have looked over the objectives and done some review, the next step would be to gather your preparation materials. These may be materials to help you to go back and review those objectives that you didn't know, and then after that to help you to practice taking the test. So preparation materials can be found at the ETS website. So we'll go ahead and take a look at those first. So here at the ETS website, under preparation materials, you need to select your test by name. So I've already done that to make sure that we're on the mathematics content knowledge test. And right below that, you do see the first thing is your study companion, which we've also, looked at that, but you should actually look at that in its entire, 51 pages. I only glanced at a couple of different things on there. And then there are other free test preparation materials on there as well. They do give you demonstrations of what the computer delivered test will look like and tell you what to expect, and also give you some information about calculators, which we will also talk about here in a bit. In the left margin are, some different ways. They give you some strategies and tips, talk about developing a study plan, and then there are also some webinars there that you can also use to help you to prepare for the test. In addition to the ETS website, other preparation materials can be found at bookstores, online, Amazon, and also in libraries. Your school library, public library, maybe your home library. You may have materials that you saved also that would be useful. The final one that I have listed here is the passpraxis.com, our tutoring website. So here you can get information on the classes and the tutoring available that will also help you to prepare and pass the Praxis test. So as a tutor, I provide the materials that meet the test objectives. So when you need to search for materials, you need to make sure that you're looking for the right materials. However, if, as a tutor, I do provide those materials that meet the test objectives. I do that search for you, and then also I can tailor them to suit your needs. So if you are struggling in certain areas, or you need to, address more attention to one area, I can pull more materials for that area, maybe give you some websites and things like that you can do additional practice or research on certain topics. So once you've looked over the test objectives, gathered your preparation materials, have done research on those objectives and the different topics that you are unsure of, the next step would be to practice and prepare. So the first thing you want to do is download the online graphing calculator trial. It's a free trial, and it is the calculator that is used on the online Praxis test. So you can do that at the ETS website. So if we go back, and if you recall on that other page, we were looking at calculator use. That would be where you want to go, to the calculator use section, and scroll down until you get to the tests that provide an on-screen calculator, and to where it says graphing calculator, and you want to click on this link that says a tutorial is available. And once you go there, it takes you to this site where you can click to start your free trial. So I'm not going to go ahead and click there because I've already done that, and we will look at that calculator also in using it. But that's how you can download a free trial of the calculator to become familiar with it, because the more familiar you are with the calculator, the more beneficial it will be to you. In addition to the graphing calculator, you should also familiarize yourself with the formula sheet. These are the formulas that will be provided to you when you're taking the test, so you don't need to memorize them. The formula sheet can be found in the study companion. So back to the study companion, on page 23 is where the formulas that will be provided on the test are. So you can, again, scroll through those and familiarize yourself with those, so you know these are the ones that you don't need. So the first page there are many notations, lots of formulas for trig that are on there, and some other formulas. So it's about 3 pages there. You have your geometry formulas, some calculus formulas as well. So those are things that, again, that are provided that do not need to be memorized. Once you are familiar with the formula sheet and have downloaded the online calculator, then you do want to take practice tests. You want to try to simulate the test-taking experience as much as possible and just practice, 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 because there are many different kinds of problems similar to what you may run into on the test. So the more you can practice, the better off you will be. And so that's what we're going to do here. We are just going to go through some different questions that are found on practice tests that are similar to what you may encounter on the actual praxis test. So this first problem that we're going to look at involves the graphing calculator. So here it is. And the problem states, a group of athletes consists of 4 swimmers, 12 runners, and 25 baseball players. From this group, how many ways can a team be formed consisting of 1 swimmer, 3 runners, and 6 baseball players? So this problem involves combinations. This is a probability and statistics problem. So combinations and permutations fall under that category. So this is a combination. Remember, a permutation is where order is important. So since it doesn't really matter what order you're putting these people on your team, it's not a permutation, it's simply a combination. And so the calculator can be very useful in finding combinations. There is a formula for combinations, but that would be one that you would need to memorize. And so we can use the calculator to avoid having to do that. So we want to form a team consisting of 1 swimmer out of a group of 4 swimmers. So this group of athletes has a total of 4 swimmers, and we just want 1 of those swimmers. So again, we're going to do a combination, and you'll have to excuse my writing on here. I'm not the best at it, but we need to take the total number of swimmers, 4, and then I'm going to use C for combination, and then I just want 1. So what I'm going to do is 4C1. For my runners, since I want 3 runners and the group contains 12 runners, I'm going to do 12C3. And then baseball players, I want 6 So I'm taking 6 of them out of a total of 25. So that's going to be 25C6. So these are going to give me the number of different ways I can combine however many I want to take out of the total. But now I have to see how many different ways I can combine those combinations. And so I'm going to use something called the fundamental counting principle, where I multiply them together. So for example, a much simpler example of that is, say, if you have 3 pairs of pants, 4 shirts, and 2 hats. How many possible outfits can you make? So you just multiply 4 times 3 times 2, which means you can combine those items 24 different ways and come up with 12 different outfits. So it's kind of the same concepts here. Once we find each individual combination, we just multiply those choices together. So now on the calculator, I am going to go here to the Math tab. So if you notice on the trial calculator, which I'm saying this, but it's not doing this at the moment, sometimes tips will pop up. So that is only on the trial version. The actual online calculator does not do that when you're taking the test. So if ever at any time now or when you're using it, you see tips that pop up, that won't happen when you take the test. So under the Math tab, I'm going to pick number. And now if you see here the key that says NCR, that's what I'm going to use. I'm going to press that key. N is my total. So for the first one, that's going to be 4. And R is how many I'm taking. So I'm going to do that over again here. So 4 is the total, R is how many I'm taking, and so that's going to be 1. And so that comes up to be 4, which so that was my 4C1. So then for 12C3, same thing, I'll use that same key, put a 12 in for N this time, and a 3 in for R. That's 220. And then for the last one, 25C6. N would be the total, 25. R is how many I want, which is 6 baseball players, and that is 177,100. So then I'm going to multiply all 3 of those numbers together. However, since they are stored in the calculator, I don't actually have to retype them in. I can just click on this little blue circle here, and it brings them up. And so then I can choose the 4 times 220 times 177,100 and get my final answer, which if you notice that matches choice B, 155,848,000. So that, again, is an example of where you really do need to use the graphing calculator. So when storing the answers, that comes in handy not only because you don't have to type it in again, but also because you don't really want to round your answers until the very, very end. So the more accurate you can keep your answers, the better. So here we have an example where, again, we're going to use the calculator, and we're going to want to use those stored values so that we don't have to round anything off until our final answer. So we're going to use this diagram for this question. The orbit of a satellite is approximately 250 miles above the surface of the Earth, which has a diameter of approximately 8,000 miles. If the satellite travels a total of about 4 million miles in space during a 240-hour period, it will orbit the Earth approximately once every blank. So in the diagram, you see the inner circle represents the Earth, the outer circle represents the orbit path of the satellite. And so we want to find how long it will take to orbit the Earth once. So we're going to be using the distance equals rate times time formula. And I'm going to use capital D, capital letters, just because also in a circle you have your diameter and your radius, which are usually represented with lowercase d and r. So we're going to do distance equals rate times time. So in this problem, we need to find out how long it's going to take to go around once. So really we're looking for time. So I can solve that d equals RT for time by dividing distance by rate. So my time is going to be my distance divided by my rate. So the distance the satellite travels is the circumference of the outer circle. And circumference of a circle is pi times the diameter. So the diameter of the outer circle, actually you have 8,000, which is the diameter of the inner circle. And since the satellite is 250 miles above the surface, not only is that 250 miles over here on the right side, but it's also 250 miles over here on the left in the diagram as well. So if you add 250 to 8,000 twice, you're going to get a diameter of 8,500 the whole way across this circle. So to find the circumference or the distance the satellite travels, we're going to take pi times 8,500. So I'm not going to do that yet because it's going to be easier if I just wait to pull the calculator out all at one time. So once I know the diameter, remember I'm looking for the time, so I need to take the diameter and divide it by the rate. So that's where the other information in the problem comes in. So to find my rate, I'm going to think about it. Again, if distance equals rate times time, my rate will equal the distance divided by the time. So I'm going to take that 4 million miles because that's the distance. And I'm going to divide it by the time. It will travel 4 million miles during a 240-hour period. So 4 million gets divided by 240. And that's going to give me the rate the satellite travels. And then once I find the distance and the rate, I can divide the distance by the rate to get the time. So I'm going to go ahead and get the calculator out to do so. So on the calculator, I have the pi key, so I need the pi key. So pi actually is under trig on the calculator. There you see pi. So you definitely want to use the pi key, not 3.14, because pi is more accurate. So we're going to take pi times 8,500 to get our circumference. So I'm not going to write that down just because of space. Remember, the calculator will save it, and I don't want to round it anyway till I'm done. So we have our circumference, which is approximately 26,703.5 miles. Then I need to find the rate the satellite is traveling. So I'm going to take 4 million and divide it by 240. And I get my rate, which is approximately 16,666, and actually that would be 2/3. And remember, that's going to be in miles per hour because the distance was in miles and that was in 240 hours. So now I'm going to go back to my problem. Remember, I'm trying to find the time here, so I need to take that distance and divide it by the rate. So the distance, I'm going to pull back my distance, which was h0, and I'm going to divide it by the rate here that I just found, h1, to get the time, which is approximately 1 6/10. Remember, that's going to be in hours. So if you look at your answer choices, the answers are all in minutes. So we need to convert those hours to minutes here. So I'm going to take the 1 6/10 and I'm going to times it by 60 to get my answer in minutes. However, I'm actually not going to use the rounded 1 6/10. I'm just going to keep the answer that's on my calculator and times that by 60 to get the most accurate answer, which is just a little bit over 96. So therefore, the answer to this question is choice B, 96 minutes. So there's another example using the online calculator. In our next example, you don't need to use the online calculator, but remember it is there if you fall into a bind or get in a pinch where you don't remember something, and you can always use it. So I personally think this one might be a little bit quicker without the calculator. However, the calculator can be used. So here we have a function f of x, which equals 1 divided by 1 minus the absolute value of sine x. And this function is graphed for all x such that x is greater than negative 2 pi and less than 2 pi. How many asymptotes are there? So remember, when you have a fraction, the denominator cannot equal 0. So that's where your asymptotes are going to occur, when 1 minus the absolute value of sine x is equal to 0. So really, sine x is one of your basic trig functions that you should have a good knowledge of. And so just by knowing about that function would be enough to quickly work this problem out. If you solve that, or I'm sorry, I guess if you add the absolute value of sine x to both sides, you're going to get 1 equals the absolute value of sine x. And so that will be 0 anytime sine x is equal to positive 1 or negative 1. Because remember, you're taking the absolute value. So the absolute value of either a plus or minus 1 in here will equal a positive 1, which in turn will make that whole denominator equal to 0. And so if you recall your trig function sine x, you could either use the unit circle, or you could just think about the graph of sine x, and then you can see there are 4 places here where sine x is either equal to a positive 1 or a negative 1. So those are the 4 values that your function in the problem, f of x, will have an asymptote. You don't need to know what those values are. It doesn't ask you what the values are. It just asks you how many asymptotes there are. And so the answer is C4. Now, if you forget or just aren't thinking about how to use the sine function to answer that question, you can, again, go to the graphing calculator and graph the function, and you can see how many vertical asymptotes there are. So this is a pretty complicated function. I'm going to go ahead and get rid of the stuff on there so that it doesn't cover up the calculator. So this is kind of a complicated function to graph on the calculator, though, so that's another reason why you definitely want to download that trial so that you can practice and be as efficient with the calculator as possible. So up here you have a little graph on the top right of the calculator, and there was one of the tips that I talked about that will pop up on the tutorial but not on the actual test. So I'm going to go down here and click on New, and I'm going to enter the function in the problem here where it says y of x. And so I'm going to do 1 divided by, for the fraction bar, going to need a parenthesis. Remember, if you have more than one term in the numerator or the denominator, you have to put it in parentheses. So 1 minus, now comes the absolute value. So down here where it says f of x on the bottom, I'm going to click on that, and below math is number, and you see ABS. So I'm going to choose ABS for absolute value. And in parentheses here where it's highlighted blue, I'm going to put in sine of x because that's what's in the absolute value symbols. Sine can also be found by clicking on that f of x key down or under trig. And for that value inside of sine, I'm going to type in x. So be careful. I have 1, 2, 3 pairs of parentheses, so I have to match up that third pair there by closing the first parenthesis that I added on there. So once I have that all entered in, I can click on, okay, actually I'm going to go to preferences because I'm looking for values of x that are greater than negative 2 pi and less than 2 pi. Since pi is approximately 3.14, when you multiply that by 2, you're going to get 6.28. And so I'm going to make my x min like negative 6.5 and max positive 6.5 so that I can just cover that with a little bit extra just to make sure I don't cut those endpoints off. So I'm going to use that as my window there for my x's. And now I'm going to go ahead and click on graph, and you can see the graph. And you would have your vertical asymptotes. Of course, they don't show you those on your graphing calculator, but those, remember, are where the graph approaches but will never touch. So there are, and usually they're drawn as dashed lines, but that's going to take me a little bit longer, so I'm just going to make them solid. There are 4 vertical asymptotes in that graph. So you can use the graphing calculator if that's a more efficient for you. You can use it, instead of actually doing calculus, if you see problems where you're asked for minimums, maximums of functions, that normally takes calculus to do it analytically. It might be quicker for you to just plug it into the calculator and find your minimums and maximums that way, because down here where it says analysis, you can find, actually, I'm sorry, it's up at the top where it says analysis, you can find those things, zeros, minimums, and maximums. There's a table you can trace to find specific functions and so on. So sometimes it is quicker to put graphs into a calculator and find those things that way rather than doing it analytically. The next problem that we're going to look at involves the formula sheet. So on the formula sheet that I showed you in the study companion was a formula called de Moivre's theorem. So I have a clip of that here showing you what it looks like from the formula sheet. And so if we look at this question, it says if z is equal to 16 times the quantity of cosine 100 degrees plus I sine 100 degrees, which of the following represents the square root of z? So if you notice the parentheses here, you have cosine 100 degrees plus I sine 100 degrees, which looks very much like the left side of de Moivre's theorem, cosine theta plus I sine theta. So theta would be your 100 degrees. The only, a little bit different because you don't have the 16, but that is just a constant multiple. So that usually doesn't come into play with changing formulas and that sort of thing. So you need to find the square root of z. So what you can do is take the square root of both sides of the equation in the problem. Because remember, in an equation, you can do something to one side as long as you do it to the other side to keep it balanced. So then by doing that, I have an expression that represents the square root of z. So I can take the square root of both factors underneath the square root symbol. So the first factor is the 16. The square root of 16, of course, is 4. And then this quantity, instead of putting it as a square root, I can take that cosine of 100 degrees plus I times the sine of 100 degrees. And instead of taking the square root, I can raise it to the 1/2 power because that's what taking the square root means, raising something to the 1/2 power. So now if you notice, that looks, this part right here, excluding the 4, looks very much like the left side of de Moivre's theorem. I have my 100 degrees would be the theta, and I also have it raised to a power. Now the k would be the 1/2. So I can apply the formula to get an expression looking like the right side of de Moivre's theorem here, which represents or looks, more similar to what's in your answer choices. So I'm going to bring down the 4, and I'm going to rewrite the rest of it so that it looks like the right side of the theorem. I'm going to rewrite it as cosine k times theta would be 1/2 times 100. plus I times sine k theta, which again would be 1/2 times 100. And then just simplify. So bring down the 4, and 1/2 times 100 is 50. So that becomes cosine 50 plus I sine 50, which if you look over to the left matches answer choice C. So that problem, the formula sheet definitely comes in handy. De Moivre's theorem is on the formula sheet. It is not something that you would need to. As you're taking your practice test, of course, not only do you want to check your answers, but you want to look at the solutions and understand how to do the problem. And then you can make a note of the things that you've missed on a flashcard, or maybe eventually make up a study guide or something like that, so that you can go back and review that also throughout your preparation period. So, for example, the solution to this problem talks about something called the central tendency theorem, which is a part of the central limit theorem. And so that might be something that if you miss this particular problem on the practice test, you would want to make a note of so that you can go back and review it again. So the problem states the average content of a sample of 900-gallon containers of healthy farm milk is 1 gallon with a standard deviation of 0.05 gallons. Based on the results of this sample, which of the following provides the best estimate of the population of healthy farm gallon of containers of milk? So in statistics, one thing that is involved is finding samples and finding statistics of the samples and estimating those to an entire population. And so the average will always be the same. And so since the average of the sample is 1 gallon in the population, it's also going to be 1 gallon. However, the standard deviation will change as you gain more elements in the population. And so to estimate the standard deviation of the population, you need to use, like I said, what the solution calls the central tendency theorem. So I'm just going to abbreviate here. The estimate is equal to the standard deviation of the population divided by the square root of the average. And so to find our estimate for standard deviation, we're going to take the sample standard deviation of 0.05 of a gallon, and we are going to divide that by the square root of 900, which is 30. And so this may be something you would want to do the calculator. I've already calculated it though. 0.05 divided by 30 is your 17 thousandths. And so again, the average is the same, but the standard deviation will be 17 10,000ths gallons. So the answer to that question is choice B. Whoops, so I didn't circle that very well, but there you go for that one. So again, make sure you're checking those answers and also looking at the solutions and making a note of the things to come back and to review again before you take another practice test. Another example is one that I actually, when I first took this practice test, had to look up for a little bit more information, because ellipses are also something that you don't encounter all the time, and so you may forget the specifics about an ellipse. And so they did show how to do this in the solutions, but a little bit more information just gave me a better understanding of the problem and helped me to remember more about ellipses. And so for this one, I actually just Googled it, and I found some information on a website called hotmath.com about ellipses. So again, making a note on note cards or making a note so that you can go back and review it is fine, and then you may need to refer to some of those other things in your library or the website for more information on the topics. And so Hot Math, this website just, kind of tells you what an ellipse is. It talks about the major axis and the minor axis, and also shows you the equation of an ellipse and the standard form here. So we're going to use this here. So horizontal major axis, your ellipse is going to look like this. And then for the vertical major axis, A is your larger number. And so notice the A squared is here and the B squared is there. But also notice they are equal to 1. And you have these quantities squared. So when you are wanting to graph an ellipse, you do need to put the equation in this standard form by completing the square. So that's what we're going to do here, because the question says, which of the following points both satisfy the equation of an ellipse given by x squared plus 4y squared minus 12x minus 64 equals 0 and is farthest from the center of this ellipse. So in order to satisfy the equation, it has to be on the ellipse. And so the one that's going to be furthest away from the center is going to lie on the major axis of the ellipse. And the major axis, again, is found by putting your equation in the standard form. So we'll do that first by completing the square with the x's. So we only need to complete the square with the x's because if you notice, we have an x squared and then we have a minus 12x. So I'm going to have to complete that square, which means I'm going to skip a little space here, and then I'm going to write down the plus 4y squared. I don't have to complete the square with the y since I only have a y squared term. I don't have a y to the first power. I'm going to add the 64 to both sides of the equation to get it over here on the right side, away from everything with my x's and y's. So there's my 64. So now I'm going to complete this square. So to complete the square, I have to look at the number in front of the x, which is negative 12, and I have to take half. I don't really have to worry about the minus sign. That'll come in when we factor. I'm going to take half of 12, which is 6, and then I'm going to square that, which is 6 squared, which is 36. Then I'm going to add that to both sides of the equation. So I'm going to add it over here to complete the square. But remember, in an equation, whatever you do to one side, you have to do to the other side to keep it balanced. So now I can look at these three terms right here, and I can factor them by now that I've completed the square. So that actually factors into x minus 6, the quantity squared. Then I'll bring down my plus 4y squared. And then on the right side, I can add the 64 and the 36 to get 100. So if you recall, our standard form had a 1 to the right of the equal sign, not a 100. So that means I'm going to have to divide everything in this equation by 100 to get a 1 on the right side. So I get x minus 6, the quantity squared, divided by 100, plus 4 over 100 can simplify into 1 over 25. So the second term here I can just simplify into y squared over 25. And then on the right, 100 divided by 100 is 1. So there I have my equation in the standard form of an ellipse. So because this is x minus 6, that means the center of my ellipse is at positive 6, 0, because there is nothing with the y squared. It's all by itself. The y coordinate is 0. My a is 10, since 100 is 10 squared. And my b from the standard form is 5, since 25 is 5 squared. So what that means is I'm going to plot my center, 6, 0, And to graph my ellipse, since A is 10, and that's under the X, that's horizontal, I'm going to go 10 units to the right and put a point, and 10 units to the left and put a point. And since B was under the Y from the center, I'm going to go up 5 and down 5. And I'm going to apologize to you ahead of time because I have a hard enough time drawing an ellipse that doesn't look like a football on paper, let alone on here. But I'm going to draw the ellipse through those points. Not exactly, but hopefully good enough so that you get the idea there. So my ellipse is going to look something like that. So back to our question, we're looking for the point that is furthest from the center of the ellipse. And so again, those are going to be these points on the major axis. So -4, 0 is on the left, 16, 0 is on the right. And only one of those is a choice, and that is B, -4, 0. So sometimes those online tutorials, things that you find online, can also be very helpful when understanding questions because, of course, the solutions provided with a test usually aren't enough. Or as a tutor, having a live tutor explain things to you where you can interact and ask questions as well is also more beneficial than just the written solutions. So you want to make sure when you are taking your test that you want to take, your time and read through things carefully. So for the next question, you do want to make sure that you're careful because they do have some of the answers set up for anticipated mistakes. So here we have a diagram showing a length of fence where a length of fence 180 feet long will be used to create 10 pens for holding animals. And we need to find the following equation that represents the total area A of the pens as a function of X. So since the entire shape, the big shape, is a rectangle, we know the area of a rectangle is length times width. So we have one dimension of the rectangle labeled with X. We need to find the other dimension of the rectangle so that we can multiply it by X to find a function that represents our area. So if we go back to our problem, we have a length of fence. The entire length of our fence is 180 feet long that we're going to use to create these 10 pens. So if we look at all of our X's, we have a total of 6 of them. We have one X here. So there's 1. We've got 2, 3, 4, 5, 6. So the X represents all of those vertical lengths. So there are 6 of them. So we're going to subtract those 6 X's or those 6 lengths, and that tells us what's left for the 3 horizontal lengths. So be careful, there are 3 of them. So one of these answer choices, I think it's D, is set up to just where, there are 2 of them, forgetting about the middle one, because that's a common error. But if you look at the top, the middle, and the bottom, there are 3 horizontal lengths. So to figure out what each of those are, we're going to divide this by 3. So 180 divided by 3 is 60, and 6 divided by 3 is 2. So that expression divided by 3 is 60 minus 2x. So that means this side of the big rectangle would be 60 minus 2x units. So once we have those 2 dimensions, we can find our total area by taking x times 60 minus 2x. And if we distribute that x through, that is going to match answer choice C, 60x minus 2x squared. So again, be sure to take your time and don't miss any details of the diagrams as well as the problems. This next question combines some algebra and geometry. We're going to use this diagram to find an equation of line AB. So quadrilateral ABCD is a parallelogram. What is an equation of line AB? So writing an equation, the most useful formula is point-slope formula. You can use slope-intercept formula to write an equation of a line, but in calculus and the higher math courses, point-slope formula is generally used when you don't have the y-intercept. So that's your y minus y1 equals m times the quantity x minus x1. So again, that's point-slope formula. And so we're looking for an equation for line AB. So to use point-slope formula, we need a point and we need the slope, hence the name. So we do have point B, 5, 2, but we don't have the slope, or we don't have point A to calculate the slope. So our point here, 5, 2, gives us our x1, y1. So here's where the geometry part comes in. Our quadrilateral is a parallelogram. That means your opposite sides are parallel. So AB is parallel to DC. So we can calculate the slope of DC, and AB will have the same. So our slope here, we're going to do y2 minus y1 over x2 minus x1. So that's going to give us 4 over negative 3, or negative 4/3. So since the slope of DC is negative 4/3, the slope of AB is the same, since it's a parallelogram and they are parallel. So now that we know the slope and the point, we can go ahead and plug them into point-slope formula. So that's going to give me y minus 2, since that's my y coordinate, equals my slope, negative 4/3, times the quantity x minus 5. So 5 goes in for x1. So notice the x and the y stay. I just replace the x1, y1, and m with those three numbers. Now if you look over the answer choices, they're written in standard form, which means I need to manipulate and rearrange this equation to get it to look like the answer choices. So first thing you notice, there are no fractions, so I can get rid of my negative 4/3 by multiplying everything by 3. So if I multiply the left side of my equation by 3, I have to do the same to the right side, but that's going to give me 3y minus 6 on the left. And then on the right, my 3's will divide out here. And so I get negative 4x plus 20. And still, though, I have to get my x over on the left side with my 3y. So that means I want to add 4x to both sides. But I can't have that minus 6 on the left. So I will add 6 to both sides also. So that's gone from the left. So notice now on the left, I just have 3y plus 4x, and then these are gone from the right. So 20 plus 6 is 26. So 3y plus 4x equals 26 is answer choice D. Okay, our next question is functions and finding zeros, and it's an application problem. So you do want to make sure that you read it carefully because there are lots of words involved. And here we have an object placed in a tank of water for 24 hours, has a temperature modeled by the function h of t, where t is the number of hours in the tank. At what time t is the temperature of the object equal to 0? So h of t is our temperature, and we need to find where that's equal to 0. So we need to find the zeros of this function, which means you want to set it equal to 0 and solve it. So this works out well because it's already in factored form. So I'm just going to rewrite the function and set it equal to 0. Sometimes if it's not in factored form, it might be quicker or it might be necessary to use a calculator to find the zero. So we will take a look at that here in the next problem, in our next and last final problem also. So this one, however, is already factored, and so you can just set all of your factors equal to 0. So I have my first factor of t, don't forget that one. So t will equal to 0, t plus 2, t minus 15, and t minus 30 all have to equal 0. So one of them could be 0 or All of them could be 0 to get a product of 0. So once you set all your factors equal to 0, you want to solve. The first one, nothing to solve there. It's already solved. But this tells me t could be -2, t equals 15, or t equals 30. So if you notice, choice A does encompass all 4 of those, 0, -2, 15, and 30. However, remember, this is an application problem, so we have to be careful here. T represents time, so time cannot be negative, so we have to eliminate the -2. And if you notice, choice B has those 3, 0, 15, and 30, but that's not the answer. We want to go back and read the problem carefully. We have an object placed in a tank of water for 24 hours. So our answer has to be between 0 and 24. So we are not going to include 30 in our answer because it's only been in there for 24 hours. So the actual answer to this question is choice D, 0 and 15. So again, take your time, make sure you read the problem carefully, and make sure you're answering the question. Our final problem that we're going to look at in this session involves calculus. It is, what is the area bounded by the graph of h of x and the x-axis? So anytime you're looking for area, you want to integrate. And a graph is always useful. It's helpful to visualize, what you're trying to find. So I'm going to bring up the graphing calculator here. And sometimes, if it's a simpler function, you might just be able to sketch a graph quicker by hand. But this one, the calculator is probably going to be the best method because we're also going to use it to find zeros. So I'm going to plug that into the calculator just like I did before. So under graph, by y of x, I want -3x, and then under f of x, math, I can find my squared. So -3x squared plus 3x plus 6 is what I'm going to graph. I'm going to leave this window alone. I'm not going to change it like I did the last time. So here's my function. It's a parabola, and I'm looking for the area bounded by this graph and the x-axis. So I'm looking for this area in here. So I need to integrate. And in order to do that, I need to find the zeros, or where this function crosses the x-axis. So a calculator is not necessary to do that because you can factor this and set it equal to 0 and solve it like we did in the last problem. And if you're good at factoring and you can do that quickly, that may be the way to go. But since I have the calculator here, another option is to use the calculator. So if I choose analysis, I can choose 0, and it moved it, so my highlighting's a little bit off. But I need to click here and drag it to encompass that 0 on the left. So if I put that between the two bars that you saw, it shows me that 0 is -1. Of course, it appears to be -1, but I want to be accurate, so I want to use the 0 function to find that for sure. So I see one of my zeros here is -1, but I have another one here on the right, and so I'm going to go ahead and click to the left of that and drag that line to the right side of where I think it crosses the x-axis and let go. And that's going to tell me down here below x is 2. So my zeros are -1 and +2. So what I need to do is I need to integrate this function from -1 to +2 to find that area. So I'm integrating with respect to x. So in order to do that, I want to use the, whoops, I just wanted to get rid of the highlighting, not everything here. So let me write that again, from -1 to +2. Okay, so to do that, I do need to use the power rule for integration. And so I can bring down the -3. So to integrate x squared, since the exponent is 2, the power rule says to add 1. to make it a 3, and then divide by that same exponent, 3. Then I want to bring down the plus sign and this 3 in front of my next term. And this x has an exponent of 1. So now for the power rule, I'm going to add 1 to 1. So that becomes x squared. And so I'm also going to divide by 2. And then plus, when I integrate 6, it becomes 6x. So I'm not going to put the plus c on here like I would with an indefinite integral because this has the -1 and the 2 that I need to evaluate it from. So this is a definite integral, so my answer is going to be a number. So to evaluate it, I want to plug the 2 into the function first. So that's going to give me -3 times 2 to the third power over 3 plus 3 times, actually, I think since I have the calculator out, why don't I just do this? Because if you notice, it says you can trace and evaluate. So actually, I'm sorry, I take that back. I was thinking about something else. So I'm going to go back to the way I was doing this, and I'm just plugging the 2 into the function. -3, I'm plugging it into the antiderivative, not the original function, which is what's on my calculator. That's why, on second thought, I can't use that graph. So I'm putting 2 into the antiderivative. So I'm going to continue that. So I have plus 3 times 2 squared over 2 plus 6 times 2. So then I'm also going to plug the -1 into the antiderivative, and I'm going to subtract that from the first value. So I'm afraid I might run out of room here. So -3 times -1 to the third over 3 plus 3 times -1 squared over 2 plus 6 times -1. Okay, so I would, possibly do this on the calculator if it's quicker. I'm just going to continue to work it out by hand here. So I have -3, 2 to the third is 8. Two squared is 4, times 3 is 12, divided by 2 would become 6, and then 6 times 2 is 12. Okay, so those 3's are going to divide out there. So then my minus sign, so then when I plug the -1 in, that's going to be a -1 times a -3. I'm sorry, -1. Yes, -1 to the third power is -1. So this is all just 1. And then this becomes 3/2. And then that becomes -6. So in this first set of parentheses, I have a negative out front here. So -8 plus 6 is -2. -2 plus 12 is 10. Minus 1 plus 3/2 is 1.5. So that's 2.5 minus 6 is -3.5. So 10 minus a -3.5 is 13.5, and 13.5 is equivalent to D, 27/2. So there you have it, some questions from practice tests and hopefully some tips to go along with them about test taking. So in addition to those tips specific to the problems, you do just want to make sure that you schedule time each day to study. So don't try to cram right before the test or, once a week or once every 2 weeks. You do need to do it a little bit at a time, whether it's sitting down, taking an actual practice test, or studying the things that you need to study. So, of course, you first want to start with the objectives needing the most attention. And as you're going over those, you can make flashcards, study guides, any way that you are best to study for a test. There are also online resources that you can use as well to study. So I have a couple of them listed here. So one very good math resource is Khan Academy. So in Khan Academy, I'm not going to go into here and show you, but just like it says, you only have to know one thing. You can learn anything. And so they have tutorials, videos, and also practice opportunities for you. So if there's something you need further review on, you can go there, you can type it in, and they have a variety of resources that you can use. We also have another online resource called Quizlet, which is mostly for studying. So this really doesn't give you the information, but it's a good study resource where you can create a study set, or there are a lot of study sets on here. So since our last question dealt with integration, I'm just going to type integration in. So let's say, that's something that you need help with, and you can make up your own study set, or you can look here, and if you see, there are study sets that people have already put in here. So if we choose this first one, it is all of the integration, your basic integration formulas. So if you just need to memorize those formulas, they're there. You can do that from the list, or you can click on flashcards. There are, it'll put them in flashcard form where it gives you the answer of the formula. So that is what you get when you integrate du. You get u plus c, for example. Or you can click on the learn, and for that, you can actually type in the answer also. So there are some different options there on how you can go about studying. But Quizlet is a very good resource for helping you to study, or you could just type in the Math Content Knowledge 5161 and see what is on there for the specific test. And Khan Academy is a very valuable resource for tutorials as well as practice. So I hope that you found this session helpful. Remember, my name is Malan Carnes. I am a tutor through Butler County Community College for the Praxis Mathematics Content Knowledge 5161 exam. Our program coordinator is Tracy Hack. And so I just want to say good luck. I know that you can do it if you put your plan in place and go for it. So I hope that you found this session helpful. If you have any questions, please feel free to email me with at the email that you see there on the screen. Once again, good luck and goodbye.